Hi everyone. This will wrap up our discussion of our discovery of inverse trig functions. We have discussed inverse sine and inverse cosine, and now it's time to discuss inverse tangent, or tangent inverse. To start that discussion, let's remind ourselves what we know about tangent of x. We know that the period is pi over b. And here my coefficient of x is a 1x. So if I were to calculate the period, I would ask myself pi divided by 1 is pi. So that's the distance it takes for the graph to repeat. And for a count by, there is one key point, so we need 2 total, which has us dividing by 2 or multiplying by a half. So let's see what that will look like when we graph. It's our standard practice to pi, 3 pi over 2, and 2 pi. And then we can also count in the negative direction. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Our a value is still 1. We have an invisible 1 in front right here. So that tells me 1 and negative 1. Sorry about that, that was the phone. I am back. So recalling our conversation of where tangent starts, if I was on the unit circle, let's bring in some prior knowledge here. Let's consider what happens here at 0 pi. And our ordered pair there on the unit circle would be 1, 0. Tangent, that is supposed to say tangent, let me try that again. Tangent of 0 pi, or 0, is going to be y divided by x, which is 0 divided by 1, which is 0. So tangent does start right here at the origin when we're graphing tangent of x. The period is a total distance of pi. So my first asymptote is at pi over 2. Recall that as we looked at the rate of change as this radius travels the unit circle, as I approach pi over 2 right here, let's say I looked at an ordered pair right here, that was a very large y divided by a very small x, and we tried a point, reasoned it out, and we realized that as these points approach pi over 2, they are going to get infinitely big. Quarter point at 1. So that's why we have this portion of the tangent graph approaching pi over 2 as an asymptote. It will get infinitely close to pi over 2, approach forever and ever and ever, headed towards infinity. In similar fashion, in that discovery activity, we discovered the same happens when we approach negative pi over 2. So you can always go back and watch that. That was a really good discovery video. And if I check the period here, the distance between these asymptotes should come out to be pi. And if I check, pi over 2 plus pi over 2 is 2 pi over 2. And the reason we know that this is the period is because if I go another distance of pi, which would send me to here at 3 pi over 2, the graph repeats. That wasn't graphed very well. Let me try that again. And the graph will continue to repeat every period, which is a distance of pi. And it keeps going and going and going and going. Like if I were to graph this little half, we'd have this half right here. Goes on forever and ever and ever and ever. So now we've had a nice little refresher on how to graph tangent. Let's now get into our conversations about the horizontal line test. If I were to graph a horizontal line through this graph as it is right now, notice fails, 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 fails. It's going to fail horribly. Meaning that if I were to just consider tangent of x all by itself with no restrictions, its inverse is definitely not a function. So we need to ask ourselves, what part of the tangent graph can I keep and still have it pass the horizontal line test? So starting at the origin, if I head right, this section is good to go, but I really can't look anywhere here or here because then it would fail. So now I'll head to the left and I can continue to follow this portion of tangent downwards, and that's still okay, but we can't look at this piece or this piece because, again, it's no good. It would fail. So we have our answer. It is this portion of tangent of x that we will restrict our graph to so that the inverse does exist. So let's discuss what this restriction is going to look like written algebraically. So tangent of x restriction. So let's see, my x values, looking at the domain, I come in from the left, it's going to be negative pi over 2, but notice I will never equal negative pi over 2. So that will be parentheses, negative pi over 2, comma, I should say pi, negative pi over 2. And then when I come in from the right, I approach pi over 2, but tangent of x will never equal pi over 2. We established that those are our vertical asymptotes. It's where the slope is undefined at each of these values. Now our range, if I take a look, I come in from the bottom, I hit negative infinity, and from the top, positive infinity. So my range is all real numbers, or you can say negative infinity to infinity. Let's now consider what this will mean about inverse tangent. Recall that inverse, in its simplest definition, is the switching of inputs and outputs. So what that means for us is that if the domain was negative pi over 2 to pi over 2 for tangent, that will become the range for inverse tangent. And if all real numbers was the range for tangent, that is now the domain of inverse tangent. If it helps to write what I'm about to write in blue, please feel free to write it again. Otherwise, as a reminder, up until this point, our input was an angle measure. And our output, in this case, recall that tangent is not one particular side length. It was the ratio of the y side length. So this actually might be good to write down because it's not exactly like what we discussed. Because tangent is a little bit different here, right? The output is the ratio of the y side length to the x side length. So now, if we switch our inputs and outputs, our input is going to be that y side length x side length ratio, and our output will be the angle measure associated with that ratio. Just like we've done up to this point. So press pause. This blue piece is super important, just like it was super important for sine, inverse cosine. Before we can start looking at examples, we have to kind of reason, what does this mean for where we are in the unit circle? So let's get that in our minds. Tangent of t, or angle t, is the ratio of sine of that angle divided by cosine of that angle. Or you could recall it as y divided by x. So if I were to sketch a little unit circle here for myself, let's consider the range restriction. The range of inverse tan, or tan inverse, is restricted. What is the restriction? Take a look and see if you can finish what I'm about to write. What is our restriction on the range of tan inverse? If I look right here, we just discussed it. It's restricted to negative pi over 2, comma pi over 2. So let's see where that puts us on the unit circle. Here's 0. To get to pi over 2, I would be going, it's positive, so I go counterclockwise and stop at pi over 2. Now to get to negative pi over 2, I'm back here at 0 pi, or 0, and now I am heading in the negative direction, clockwise, and I'm going to stop when I hit pi over 2. Excuse me, negative pi over 2. But notice we have a new piece here. Remember, these parentheses mean I cannot equal those two values. So please clearly make an open circle at each of those points. We cannot equal negative pi over 2 or pi over 2. So this means we are restricted to the right side of the unit circle. Right side of the unit circle, not including negative pi over 2 or pi over 2. So I can consider, or I will be considering, inputs that are connected to that y-x ratio for angles strictly on this right half of the unit circle. So now that we have that in our minds, let's take a second to consider what are these possible ratios, because I'm not going to be given the ratio in the works, so to speak. I'm going to be given the simplified answer. So let's talk possibilities. I know that if I'm dealing with pi over 4, that ordered pair is what? What ordered pair has always been connected to pi over 4, 45 degrees? The answer, I hope we're saying, is root 2 over 2, comma, root 2 over 2. The tangent of pi over 4 would be, here's x, here's y, or cosine and sine. Sine divided by cosine, which would be root 2 over 2 divided by root 2 over 2. This is all prior knowledge, just bringing it back, which would equal 1. So if I'm given the inverse tangent of 1, I need to be able to reason backwards and get to pi over 4. That's what we're going to practice in a minute. Another possibility would be pi over 3. What ordered pair on the unit circle is connected to pi over 3? Think of the triangle, the reference triangle that would be created if I sketched pi over 3. That would be a short x and a long y. So once again, considering the tangent at that point, tangent of pi over 3 would be y divided by x, so that's root 3 divided by 2 divided by 1/2. Again, for emphasis, this was y divided by x. You have a choice of keep, change, flip. So keep the numerator, change to multiplication, flip the denominator. Or we've also practiced that the result of that, if we're dividing a fraction by a fraction and the denominators are the same, when we do keep, change, flip, those 2's cancel. The result is root 3 over 1, which is just root 3. So if I was given inverse tangent of square root of 3, I need to have the skills to work backwards to realize that's connected to pi over 3. Our last possibility would be for 30 degrees, which is pi over 6. Once again, when I say visualize what would be created there, here's pi over 6. If I were to create that reference triangle, here's my long side, short side. So the long side is x, root 3 over 2. Short side is y, which is 1/2. Here's my x and y, or cosine and sine. And again, let's figure out what the tangent of that is. So tangent of pi over 6 would be y, which is 1/2, divided by root 3 over 2. Those 2's cancel when we do keep, change, flip. Our result is 1 divided by root 3. And we're not done yet because we can't have a square root in the denominator. Rationalizing gets us root 3 divided by 3 as an answer. So all three of these are kind of visualized as going forwards, where we were given our angle and we had to go find that XY ratio. That's all prior knowledge. We're now going to learn how to go backwards. So if you want to put that kind of like in a brain bubble, this was all prior knowledge, but reviewing that prior knowledge is going to help us in what we're about to do. Let's see how. Example 3 is all about evaluating inverse tangent or tangent inverse functions. Number 1 is inverse tangent of root 3. So big picture, let's reason on what's being given here. If I have inverse tangent, that means I am being given, that says being, sorry, let me write that again, being given the y divided by x ratio. That's what this is. This is the result of y divided by x. I have to figure out what angle measure or what angle measures cosine, sine, ordered pair gets me that result. So let's work backwards. I know I have root 3 as my answer, and I know that came from some y divided by some x. From our prior knowledge that we just talked about, we know when we're on the unit circle dealing with 45, 30, or 60 degree angles, or the radian measures pi over 4, pi over 3, or pi over 6, our possible side lengths that we could be working with are root 2 over 2. That's not going to help me here. And then we've got 1/2 and root 3 over 2 for grabs. Those are the two that we might find useful here. So if I know I'm trying to have root 3 as an answer, in my brain, because I know my side lengths, I automatically know that these are the side lengths I'm working with, and this is the order. Because I know when I divide those fractions, the 2's will cancel, and that's what I will get as an answer. So that's why we started off by remembering how to go forwards, right? This whole little brain bubble was remembering how to calculate tangent of pi over 4, pi over 3, pi over 6. And remembering these are the 3 outputs. So now that I figured out which side length goes where, I'm not going to create this grid up here every time. So how do I go from here? I know that this is the correct ratio. I know that this is y and this is x. So I can write that as an ordered pair. That's going to be 1/2, comma, root 3 over 2. That's my xy ordered pair. If I sketch that, that is short x, long y. So short x, long y would put me up here on the unit circle. And when I ask myself what angle measure is associated with that xy ordered pair or cosine sine ordered pair, and my answer, and I'm hoping we're all thinking the same answer right now, is pi over 3. So tangent definitely takes some more thought. When we were dealing with sine, what was inside these parentheses was a y side length only. When we were dealing with inverse cosine, what was inside these parentheses was an x side length only. But now that we're working with inverse tangent, what's inside those parentheses is a y divided by x ratio, and I kind of have to become a detective to figure out what ratio resulted in that value. So let's practice another one. This definitely comes with some practice. Our comfort comes with some practice. So let's work on number 2 together. Arctan remember arctan is the same as tan inverse, of 0. So once again, my train of thought here is I am being given a y divided by x ratio. So for me, I actually write that down. 0 has to equal some value of y divided by some value of x. I am restricted to the unit circle, and the fact that 0 is involved tells me I am dealing with a special case. To get 0, that has to come from 0 divided by 1 or negative 1. So I'm going to leave it blank for a second, and let's reason which one it's going to be. So I've got, this is y divided by x. So the question is, do I put a 1 or a negative 1 right there? Let's see. So 1 comma 0 is right here. How do I know this is my answer and I cannot come over here? Because technically, on the unit circle, this is negative 1 comma 0, and 0 divided by negative 1 is 0. So why not? Why can we not say that this is the right answer? Our restriction, if you look back at what we discussed right here, for tangent, or excuse me, inverse tangent, we are restricted to the right half of the unit circle. So even though this ordered pair does result in 0, it's on the wrong half of the circle, I can't use it. So that's how I know I'm right here. When I ask myself what angle measure is at this point, my answer is 0 pi or 0, whichever you choose. Let's do some as a guided practice. So I'll help you start, and then I'm going to ask you to press pause, and you'll try and see how we do. So number 1 for the guided practice is arctan of negative root 3 divided by 3. So I'm going to ask you to press pause and use the notes we've taken so far to see how it goes working backwards. I'm going to help you start by recommending that you ask yourself, I know this has to come from a ratio of y divided by x. Where am I going to put my side lengths? Remembering that technically the 3 side length possibilities are one of these 3. Press pause and see if you can figure it out. When you press play, we'll see if we match. So from my prior knowledge, I think I do know that it's not going to be root 3 over 2 divided by a half, because the denominators cancel, the 2's cancel, and that's going to get me root 3 as an answer. But I don't want root 3. I want root 3 divided by 3. So what happens when I switch them? What happens if I put 1/2 in the numerator and root 3 divided by 2 in the denominator? Let's figure it out. When I keep change flip, the 2's will cancel. The common denominators here will cancel themselves out. And the result is 1 divided by root 3. When I rationalize, that gets me root 3 over 3. So I am close. Why am I saying I'm close but not done? Well, I notice here that the given ratio is negative, and I haven't actually considered what that means yet. Well, let's start our sketch and see if the sketch will help us out. From my knowledge of where inverse tan can be, I know I have to stay somewhere on the right half of the unit circle. So if I'm literally considering these as a y side length divided by an x side length, we typically move, not typically, we always move x comma y. So if I write this as an ordered pair, I know this is my ordered pair because this is y divided by x. And I've established that gets me what I need. The question is, which one of these guys is going to be negative? Well, if I have to stay on this half of the unit circle, think about it. X has to go right, which means x will be positive or negative if I'm going right. If I'm going right, it's going to be positive, which means the negative has to be the half. Let's see if that makes sense. I go right √3/2, which is a longer x, and down a half, which is a short half, a short leg. And I'm right here at positive √3/2. I went right √3/2 and then down a half. So tracing that back, the half has to be negative, makes this negative, makes this negative. Now I just need to ask myself, what angle measure gets me there? And if you are thinking and or already wrote -π/6, I agree with you. It's a negative 30-degree angle. I know that because this is long side, a long x, and a short y. So that's what influences my sketch. One more to wrap up today's notes. Inverse tan of -1. Press pause, give it a try all on your own. When you press play, I'll walk it through with you and then we'll see if we match. So I'm going to start going through the answer. At any point, if what I say helps you keep going, press pause and then try finishing it from there. So if I'm working with inverse tan, I know that the value I'm given comes from a ratio of the y side length divided by the x side length. So if that's what you needed to help you get started, press pause and finish it. Try finishing it on your own. My possible side lengths are √2/2, a half, and √3/2. Now right away, I know these guys are out because it's either a half comma √3/2 or √3/2 comma a half. I know one of these gets me √3 and the other one gets me √3/3. So these are out. I remember that it's always √2/2 comma √2/2, which is exactly what I need, because when I divide any value by itself, that equals 1. The question is, which one is negative? Because notice I have a negative ratio. So let's see. This is y divided by x. when I write that as an ordered pair, x comma y, got root 2 over 2, root 2 over 2, and let's sketch. The key is remembering I am limited to this half of the unit circle. So one way to remember it is that anything that falls in quadrant 1 is positive. That's always going to be a positive divided by a positive. Right? All ordered pairs here will be positive divided by a positive. So tangent is positive in quadrant 1. Anything in quadrant 4 will be a positive divided by a negative. So that's an easy way for me to determine I am in quadrant 4. To get to that ordered pair, it would be root 2 over 2, comma, down root 2 over 2. The angle measured to get there is not something I need for tangent because I already figured out it was 1. Not true, sorry. Brain moment. The angle measure that gets me a 1, you know what it is? I wrote that 1 so huge I made it look like my final answer. So I'm going to make it a little smaller. Okay, so we've established that the y value is negative. So, inverse tangent of -1, we now need the angle measure that gets me this ordered pair, and that would be negative pi divided by 4. That wraps up our tangent notes and should allow you access to finishing the tangent examples that are part of numbers 1 through 14. Please, as always, send any questions, and I will talk to you guys soon. Have a good night.